Good morning. I am Minakshi Sarkar, Assistant Professor of CSC Data Science. Today I am going to explain the introduction of DFA and NFA. Before that, we have to know what is POC. POC means Theory of Computation. Computation means any task that can be performed by a computer or any calculator in general. Then we are going to start a theory about it. Means what are the capabilities of this machine, what are the problems that can be solved by this machine, and what are the limitations of such this machine. So the basic building block of this subject is symbol. A symbol can be any letter, it can be AB, it can be any number 0, 1, and it can be any alphabet character, or it can be any image also. So, symbol is the basic building block of these subjects. After that, there comes alphabet set. This is alphabet set that can be represented by sigma. Alphabet set is collection of symbol. Collection of symbol. And we can write it like that. Suppose collection of symbol means A comma B. This is the alphabet set. It can be 0, 1, 2. This is another alphabet set. Then comes string. String is some sequence of symbols. Just like that, A, AB, BA, and BB. These are the string, and we can say this is the string length of 2 because all the strings we are getting here of length 2. Another string, if we consider only AB, this is also a string of length 1. Next come language. We will see here. We can get language. There are basically two types of language. One is finite language, another one is infinite language. Finite language, suppose if I say in one set of all strings of length 2. Set of all strings of length 2. That means the language set can be A, B, A, and BB. So only these 4 strings of length 2 is possible here. So this is finite language. Another one, if I consider a set of all strings of length 3. So here the set of language will be A, B, A, B, B, A, B, and so on. So I think here we will get as a set of all strings of length 3. So 2 raised to the power 3, that means total 8 strings of length 3 we will get from here. So that is also finite. So we can also call it as a finite language. But another one, if we see here, L3, set of all strings of set of all strings where each string should starts with A. Starts with A means it can be A, AB, AA, ABA, and so on. So we will get here, we can get here any length of strings which only one constraint is that string should start with A. So this is infinite language. So now we are going to the next part. This is finite automata is basically of two types, with output and without output. With output again subdivided into two parts: Moore machine and mini machine. And without output, DFA, NFA, and epsilon NFA. Deterministic finite automata, non-deterministic finite automata, and non-deterministic finite automata with epsilon moves. So now we will see all this part without that comes under without output one by one. First we will see DFA. So what is first we will see the definition of DFA. What is DFA? It is A quintuple machine. DFA, NFA, all we call it as a quintuple machine. Or we can call it also a 5-tuple machine because 5 tuples are present here. Q, sigma, delta, Q naught and F. So now we will explain all the tuples. First, if we see Q, Q is the finite set of states. Sigma is already I told you that is input alphabet. Q naught is initial state and F is set of final states. Okay, I am going to represent all the tuples here by using an example. And delta is the transition function. And the only one difference is there in between DFA and NFA, that is the transition function delta. Now we will see one example here. This is the diagram one of DFA. Total 3 states are here. The states which is represented by this arrow, this is called as the initial state. And the state which is having the double circle, that is called final state. And all other states are called some other states. Now from this diagram I will write what is Q. Q means finite set of states. How many states are here? It is 3 states. Then sigma is input alphabet. What are the input alphabets I am taking here? A and B. A and B. Small a and B. Then Q naught. Q naught is initial step. Initial step is A here. Then F is final states. As we are getting here only one final state, that is B, but sometimes we might get for another DFA more than one final state, so that is why I have told you that F is set of final states. Now we are going to say how these transitions is going to be happen here. So Q is all the states and F is only B. So I can tell you there is a relation in between Q and F. Q is superset of F. Q is superset of F. Now we will see the last part, that is transition function. Transition function is Q cross sigma goes to Q. From a given state, by giving some input, it can go to some state. Okay, and if I talk about the definition of DFA, from each state by giving some input, we can go to only one state. We cannot go more than one state by a single input. So here Q is ABC and sigma is AB. Then from A, by giving input A, I can go to state B. From A, by giving input B, I can go to state C. Just I have represented here all the transitions here, and finally we are reaching Q. So this is the transition function. Okay, so this is all about DFA. Next we will see one example of DFA. This is another example. Construct a DFA that accepts set of all strings over AB of length 2. Length 2 means it will accept only 2 length strings, and we have to generate the strings of this alphabet set AB. So what are the strings set? A, AB, B, and B. These 4 strings are here. Now first of all, we have to draw the skeleton for the smallest string AA. Now, from A, by giving input A, I can go to state B, and by giving input A, I can go to state C. AA is accepted. Now, AB and BA, I can write here B, and I can write here B. So, BA, all the strings which are present in this language, all strings will be accepted by this final state. Can you tell me, is it a DFA? No, it is not a DFA, because in the definition I told you that from each state by giving some input, I will go to only one state, but from a state for all the inputs you have to go some other state also. Here I have shown where I can go on input A and B. This is complete. B is complete also. I have shown here where I can go from here on B, A and B. But this is not complete. So that is why it is not DFA. So if I write here another A or another B, then I am going to some other state, that is D. But it will accept only two length strings. So AB, from state A, by giving input A, I can go to state B. From state B, by giving input B, I can go to state C. C is the accepted states. Okay, listen one thing. There are basically two types of states. One is accepting states, another one is non-accepting states. Here C is accepting states and all other states except it A, B, all are non-accepting states. Okay, so C is the accepting states and A, B is accepted. Now, from here, if I write here A or B, I am going to some other state, that is D. But this is exceeding the string length 2. The question says it will accept only 2 length string. So this is exceeding the string length. So that is why after this, all the strings will get automatically rejected. And this is also not DFA. From here I can get any number of AB, but all strings will be rejected after it, because once you reach here, there is no other way you can again reach to the final state, and this state is called the tail state in DFA. This is the one example of construction of DFA. And there are basically two parts. One is acceptance of string, another one is acceptance of the language. First we will see what is the acceptance of string. Suppose if I say A, only one string is A or A. Acceptance of string. The definition is starting from initial state upon scanning the entire string. If we can reach a final state, then we can say this string is accepted by this finite automata. So this A is accepted by this finite automata. So this is the accepted string. Another one is acceptance of language. That is quite different from it. If I consider the string is A, and suppose this is the DFA where initial and final both are same state. Now, is this string accepted by this DFA? A is accepted by this DFA. Yes, that is okay. But acceptance of language, the definition says if all the strings present in the language starting from initial state upon scanning the entire string, if we can reach final state, then we can say the language is accepted by final automata, as well as all the strings which are not present in this language should be rejected by this final automata. Then we can say this is the exact diagram for that language. But here this A is not accepted by this finite automata. So this is the valid diagram for this question. This is not the valid diagram because A is accepted by this finite automata. Okay. Now come to the next part, that is NFA. So first of all, I will tell you the difference between DFA and NFA. NFA is also a quintuple machine. That is, there are also 5 tuples: Q, sigma, delta, Q naught, F. Only I already told you Q, sigma, Q naught, F all are same as the DFA. Only one difference is there, that is transition function. Here Q cross sigma goes to 2 raised to the power Q. That means some power set of Q. We are going to get some subset of states are possible here in NFA. And from we have seen in DFA, from Q1 by giving some input I can go to only one state. There are no copy of this. There are no copy of the states. Okay, but in NFA, from Q1 by giving some input I am going to state Q2 or Q3 or Q4 and so on. So I can go to more than one state by giving the same input, or I can go to no other state also, that is fine. So this is the difference between DFA and NFA. DFA, deterministic machines are real, but non-deterministic machines are not real. Then there might be a question, then why are we going to study it? because there are some problems that can be solved by exhaustive search, and exhaustive search is a or backtracking. So we might get some better solution for it. And in DFA, no copy is created, but because we cannot create copy of ourselves. But in NFA, so many copies are created here. Okay. So suppose if I consider a game based on your move, some output will be decided. So suppose if I move, then this will be my output. But in case of NFA, based on some move, some number of output will be decided. So there you might be some win or you might be lose. So now we will see one example of NFA. Construct a NFA where each string ends with A. Ends with A means this is an infinite language, and the language ends with A, and over the alphabet set AB, and the language is A, and so on. So this is the diagram that is very easy once you learn NFA, and it will be quite easier than DFA. So only one constant is there, ends with A. So it is ending with A. This is the final state or accepting state. It can start with anything A or B. Okay. So now see one thing here. From suppose I am giving one string that is A. From A, by giving input A, I can go to state A, or I can go to state B also, A and B. So more than one state I can reach by giving only single input. So that is here that some copies of states are creating here. Okay. So now if we see the transition function for this NFA, delta is q cross sigma to 2 raised to the power q means power set of q. So here q is AB and sigma is a small ab input alphabet, and q cross sigma I might go to some state, or I might not even go to some other state also. So this is all about NFA. If we see another string AB, from A by giving input A, I can go to state A. From A by giving input B, I can go to state A. But from A by giving input A, I can go to state B. Yes, that is correct. But from B by giving input B, there is no other movement. So that is fine. So that is called the date configuration. So date configuration is there in NFA, and this is called date configuration. So thank you. This is all about DFA and NFA.